Hi students, welcome back to ChemOrgChem. So our JEE Chemistry Insight series, we have been exploring the solution for previous year JEE Chemistry exam papers. If you are new here, don't forget to subscribe ChemOrgChem and hit the bell icon for notification. Let's see what's today's problem. So this is the question from JEE Main 2025. So as per this question, 151 gram of 2-bromopentane, so which react with alcoholic potassium hydroxide, which produce 80% of product P, so which then further react with bromine, so which produce product Q as 100% of yield. So here we are asked to find out the mass of product Q, so in this reaction. So for this, they given hydrogen atomic mass and carbon, oxygen as well as bromine atomic mass. So in order to solve this type of question, first we should find out the product structure of P as well as product structure of Q. Once if you find the structure, next we should calculate the mole of product Q as well as molar mass of product Q. Once if you find these two important information, then we can easily calculate the mass of product Q. So in order to find out the mole of product Q, first we should find out the how many moles of 2-bromopentane involved in this reaction. So for that, so first you write it down, 2-bromopentane. So this is the 2-bromopentane, so which react with alcoholic potassium hydroxide. So here alcoholic potassium hydroxide act as a base. So in particular, this reaction is elimination reaction. In most exactly, so this reaction is E2-elimination reaction. So according to E2-elimination reaction, so here hydrogen bromide going to eliminate. So in this particular 2-bromopentane compound, there are two possibilities. The first possibility is our base that can abstract this proton, so resulting that abstraction of this proton, now this electron can move here, which kick off bromine atom. So or otherwise our base that can takes this proton, if it do so, now this electron moves here, resulting that kick off bromine atom. However, according to JEE rule, which states that more substituted alkene always preferred when compared to the less substituted alkene. So when you take this green hydrogen, which produce more substituted alkene. In case of our base, when it takes this red hydrogen, resulting that produce less substituted alkene. So therefore, according to JEE rule, our base readily takes this proton. Now this electron moves here, so resulting that kick off bromine atom, which produce this corresponding alkene as a product. So this is our product B. Now this product B further react with bromine. So in this step, addition reaction takes place. Now this bromine molecule going to add across this double bond, so resulting that produce this dibrominated product. So this is our product Q. So we successfully found the structure of product P as well as product Q. So our next step would be the find the how many moles of 2-bromopentane involved in this reaction. So for that, first we need to calculate the molar mass of 2-bromopentane, since they given 151 gram of 2-bromopentane involved in this reaction. So in order to calculate the molar mass, first we need to calculate how many carbon atoms are present in this molecule. So therefore 5 carbon atoms are present in this molecule and 11 hydrogen atom and 1 bromine atom. So in order to calculate the molar mass, they given atomic mass of hydrogen, carbon as well as bromine atom also. So here there are 5 carbon atoms, therefore 5 multiply 12, which produce 60, and 11 hydrogen atom, 11 multiply 1, which produce 11, and 1 bromine atom, 1 multiply 80, which produce 80. So when you add all these values, that give 151 gram per mole. So this is the molar mass of 2-bromopentane. So next we should calculate the how many moles involved in this reaction. So for that, moles of 2-bromopentane equal to mass divided by molar mass. So now you see here they given 151 gram of 2-bromopentane involved in this reaction. Therefore 151 gram divided by 151 gram per mole. So now 151 gram and 151 gram cancel each other, which resulting that produce 1 mole. That means that 1 mole of 2-bromopentane involved in this reaction. Okay, so next we need to calculate the how many moles of P produced in this reaction. Since we need to calculate the moles of Q produced in this reaction, for that definitely we should know how many moles of P produced in this reaction. So for that you just write the our structure of product B. Just imagine here. Theoretically, 1 mole of 2-bromopentane reacted in this reaction, that would give 1 mole of product B. By theoretically, however, here the major product of B is given as 80% of yield. So therefore, in order to calculate the actual moles of produced P, so equal to theoretical moles of P multiply by yield divided by 100. So therefore theoretical moles would be 1, and here they given 80% of product B yield. So 80 divided by 100, which produce 0.8 mole. So which means that, so here in this reaction 0.8 mole of P is produced. So next we should calculate the how many moles of Q produced in this reaction. So from the previous step, so this is our product Q. So from previous step, 0.8 mole of P reacted to produce this product Q. So here we need to calculate the how many moles of Q produced in this reaction. In theoretically, zero point 0.8 mole reacted with bromine, which should give zero point 0.8 mole of Q by theoretically. So in order to calculate the actual moles of produced Q, so here you can see that, so here Q is 100% yield. So therefore actual moles of Q obtained in this reaction is theoretical moles of Q multiply with yield divided by 100. So here theoretical moles of Q is 0.8 mole into 100 divided by 100. Since here the given yield is 100%, so which produce 0.8 mole. So therefore 0.8 mole of P reacted with bromine, that produce 0.8 mole of Q. So now we successfully find that 0.8 mole of Q is produced in this reaction. So the next step would be the calculation of molar mass of Q. So in order to find the molar mass of Q, first you write it down the structure. So here already we written the structure, and now we need to calculate the how many carbons and hydrogens as well as bromine present in this molecule. So here there are 5 carbons, 10 hydrogen atoms and 2 bromine atoms. So each carbon has atomic mass 12, therefore 5 multiply 12, which produce 60, and 10 hydrogen atom 10 multiply 1, which produce 10, and 2 bromine atom 2 multiply 80, which produce 160. Mass of Q 230 gram per mole. So now we have 0.8 mole of Q obtained in this reaction, as well as we have molar mass of Q. So now you multiply these two values. Now you can get the mass of product Q. So here you can see that 184 gram of product Q is obtained in this reaction. So next moving on our question. So as per our discussion, the mass of product Q is obtained in this reaction is 184 gram. So that's it for today's problem. I hope this explanation has helped you to understand this organic reaction as well as mole concept as well as other calculation related to find the mass of product. If you enjoyed this session, just give it a thumbs up and share it with your friends, and don't forget to subscribe Chem Orcam for much more content like this. And finally, thanks for watching. Bye bye.